Let's imagine that we have some device that has the ability to store charges, and on one side there's positive charges, on the other side there's negative charges. There's excess of both positive and negative. So we connect up a conductor and we create two metal plates separated by some distance. Now, once the plates are hooked up, connected by means of conductors to the charge source, the positive charges are going to flow through the conductor and are going to collect on the plate to the right, and the negative charges are going to be collected on the plate on the left. And all the positive charges would be pushed towards the negative charge source. So this idea of two separate plates is the idea of what we call a capacitor. So a capacitor is just two separated conductors that does not have a path for charge to flow. Charge to flow, or we can say move. So there's this disconnect in between. And capacitance is just a measure of how well a device, or we should say a capacitor, can hold charge. Because if I were to cut either of these conductors, let's say I cut this conductor over here and I cut the conductor on the left side, then those charges are going to stay on the capacitor. And so there's a certain amount of charge that can be put on the capacitors where there's an equilibrium. Now, flat plates can be difficult to handle. We like a more compact form. So what's done many times is you have a conductor and you roll it into a spiral. So there's one conductor, and then you take and roll a second conductor. Actually, let me put this in a different color just to make it easier to see. Let's make that red. So you have another conductor that gets sandwiched in between but not touching. See if I can do that with my pen here. And because the two plates are not touching, this would be also considered a capacitor. So there's many different ways that we can create capacitors, just as long as the two conductors are not touching. Now symbolically, we have what we call schematics. Schematics are just drawings of symbols to represent parts. And so for our charge source, we call that a battery, and we'll talk more about batteries later. And it has a short terminal, which is the negative side, and a larger terminal, which is the positive side. This is technically called a cell. We'll talk about that in another chapter. And then we just use lines to represent connectors. And that's connected to a capacitor, which is just two equal lines separated, parallel lines, and we have a capacitor. Capacitors are referenced by the letter C, and the units of capacitance is the farad. And that has a symbol of a capital F. So now let's find in the next video how we can determine the capacitance of a parallel plate capacitor based on its dimensions.